Yes, good day, students. Today we want to look at functions relations, right? And I've written a few notes here. It says a relation is defined as a set of ordered pairs that obeys a particular rule. It's a set of ordered pairs of x and y, right? The definition for function now is a function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. And something to pay close attention to, every function is a relation, but not every relation is a function. And you'll come to understand why this is so, right? So if you have for example, you say your x arrow 3x plus 5. What does this mean? This is saying that x is mapped onto 3x plus 5. So whatever value is given to x, it is going to be thrown into this x, and when you total everything, you're going to get the value for the range, which are the y values. Remember that the domain consists of the x values and the range consists of the y values. So for example, if we were to limit our x values between -2 and 2, this is a notation, right? This is saying that x is greater than and equal to -2, and x is less than and equal to 2, which means that -2 and 2 will be included in the set of values, but you won't have any other values less than -2 or greater than -2, so they're limited to -2 and 2. So everything falls between, including these two values, right? Says then we have the following table of values for the relation y equal 3x plus 5. So when we look at the table now, we draw the table to reflect x and y as well as 3x and 5. So as we can see, when x is -2, 3 times -2 becomes -6. And when you add the 5 to -6, you're going to get, so y becomes -1. So the relationship is between x and y, but you have to use the equation to work out whatever value belongs to x, right? When x is -1, 3 times -1 is -3. And when we add a 5 to -3, we get a +2. So the y value here would be 2. And as you work out the rest, you will see now that the ordered pairs would be between this and this, -1 and 2, 0 and 5, 1 and 8, 2 and 11. As you can see over here, the ordered pairs. So the first digit will be x and the second digit will be y. So -6, as you can see, everything is ordered here, and as you come to realize now that the domain elements are the values of x, which are 4, -2, -1, 0, 1, and 2, which is really 5, right? And then the range elements now will consist of -1, 2, 5, 8, and 11. So this is the basic introduction to functions and relations, right? Okay, as you can see in the mapping diagram, the elements in the left diagram is called the domain. These are all the x values, -2, -1, 0, 1, and 2. And over here we have the range. So for every element in the domain, there's a mapping onto the function which creates a y value. So in actual reality, then this is known as a y set of values, and these are the x set of values. As we worked out in the theory before, when x is -2, y becomes -1. Now, if this is a 1-to-1, this is known as a 1-to-1 mapping. A 1-to-1 mapping, because for every element of x is attached to one value of the element in the range. This is a 1-to-1. Now, because this is a 1-to-1 relation, it is equal to, we can safely say that this is a function. So a 1-to-1 mapping is called a function. Why? If, for example, if -2 was to be mapped onto another number in the range, then this would not be qualified to be called a function. For this mapping to be a function, only one value of x can be mapped onto one value of the element in the range, right? So that's the difference between a relation and a function. In some relations diagram, you may find that one element in the domain is mapping onto more than one element in the range. And when that happens, this mapping cannot be considered to be a function mapping. It is just called a relations mapping. That's why earlier on we said to you that not every function is a relation, but not every relation is a function. And you have to understand this, all right? It's very, very important for you to understand that. So that, as I said before, this is just a introduction. We'll go on to more videos where I'll prepare some exercises as to how you can actually map on from one diagram to the next when you're given the equation. All right, thanks. I'll see you in the next class. We'll continue with this in the next class.